So I don't know anything about dentistry, but this doesn't seem right. I don't know what's going on, but it sounds like it's screaming for help. Hey, so today we're going to be repairing this ultrasonic scaler used in dentistry. And I don't know anything about dentistry, so let's first see what the product page for this device says. And apparently it removes calculus, and at first I thought that meant this device will make it difficult to calculate the area under a curve or solve differential equations. However, it turns out that this is a word used for hard tartar and plaque on teeth. So this device is used to remove buildup on teeth. I'm guessing it fires jets of water that are pulsed at an ultrasonic frequency to kind of give it a bit of an abrasive quality, similar to an ultrasonic cleaner, but it's targeted through some of these little hand tools here. All right, so we are going to be dealing with switching components, and we're going to power it on, and we're going to see what the failure mode is, and let's move forward from there. So back to the failure mode, we see there's a squealing buzzer, we have some flickering lights, the power level doesn't move regardless of what buttons we push. This could be anything in the switching line, so transistors, MOSFETs, diodes, even the capacitors on the switch mode power supply, so we'll see what's going on here.
I see a nut on the floor. Uh-oh. And I unwillingly took out the nut. That earths the whole thing. So that center screw wasn't supposed to come out. That is for the earth. So let's go ahead and put that back in. Nice big power connector here. Oh, okay, I figured something out here. So what I've noticed is, yeah, some switching goes on here for sure. You can't look at these and say, you know, these aren't maybe an L. Could be like an LC low pass circuit or something, but what's happening is mains comes in through here, and this bottom red board is an AC to DC converter whose output is here, and that feeds into this board, which is probably the board that handles whatever this system does in serving water and some control signal from the pedal to control what happens on this the stick, this end effector. I'm calling it an end effector, like we're CNC machining, because I have no knowledge of dental equipment. But what I see, and this is what I love to see when I don't know what I'm working with, because it points a finger at something that's wrong. I don't know if you can see it on this light. Do I see some bulging capacitors? I think I do. 1, 2, and then a third one's got to be replaced. I see some bulging capacitors. If we have a power supply problem, that could very well point at our issue. The main thing is, maybe we can see, I'll take this apart further. I'll take it apart further, but if I can find out if what voltage this board puts out, it might be as easy as having it written on the silk screen somewhere here, like a label. It could say, you know, 12 volt out, 24 volt, 50, whatever out. If I find out what the voltage is supposed to be, I can measure it here. I'm going to measure it anyways. But if this looks like it's DC, right? Red, black wire doesn't necessarily mean DC, but I see a DC filter cap, right? I see this electrolytic right there. If this voltage isn't DC, or it's got a huge amount of ripple, maybe something's wrong with the power supply, and that's what the issue is. Ready? 3.5 volts DC. Doesn't look like a clean 3.5 volts DC. Why? Because it's probably supposed to be a lot higher than 3 volts. And I'm assuming there's an AC component here, because this sounds like something turning on and off really quickly, because the output is screwed because the capacitors that are supposed to filter the output to a nice DC are not doing their job because they're inflated. AC 0.6 volts. That doesn't tell me anything anyways, because the AC here isn't going to work if this is oscillating at ridiculously high speeds. In general, this is going to be tuned for like mains, like 50, 60 hertz. It'll probably work at a couple hundred hertz, maybe even a few kilohertz. I don't know for sure, never used it for that, but this is a problem. I think our power supply is screwed. First of all, bulging capacitors are bad in any case. I think we need to replace those before proceeding anymore. Alright, let's try to get this loose. Is this, oh, yes. Okay. Hold up. Okay, let's unplug these. So, I have this switch looking like that. To get this board out, yeah. Oh, power supply out. Thank you. Okay. Now, what do we have here? I see a label. 24 volt, 2.7 amps. There's a model. We could just replace this power supply if we need to. We can try to repair it by swapping out these obviously bulged caps. Look at this. See that? This one and this one look really bad. This one, not really. This one, not really. But all these will go. They're the same capacitors. Okay, new finding. I took out the two bulged capacitors just as a test, and one of them operates fine when I put 24 volts on it. The other one operated fine at 12 volts, and as I increased the voltage, it started conducting an amp. It was passing an amp through to ground, and it was getting extremely hot at just 12 volts, and this is a 24 volt power supply. So I think we found our problem. Now, hopefully that's the only problem. I've put in, I don't have exact values, so I've just put in 100 microfarad and 330 microfarad, but the voltages are spec'd over 24 volts. One's 63 volts, one's 50 volts, or no, one's 63 volts, one's 35 volts, so rated for what we need. I soldered them on the bottom because I don't want to plug up these holes because it took a while to desolder them, and if this works well, I'm going to order the same or better capacitors that can handle really high ripple currents, because I want something reliable as a replacement for this important supply. So, oh my god, okay. It's time to go to bed. It's time to go to bed. Okay, no explosion yet. Come on. 12 volts. It's higher, but it's not 24. Okay. But we have a light. We didn't have the light before. Okay, I found the solution. So we're still a bit apart here, and I fixed it. So I've swapped out the capacitors on the output because they were bulging. Got some brand new capacitors. They have the same rating and actually better. So they are rated for 50 volts instead of 35 volts. And they have a relatively low ESR. So they should be suitable replacements for these guys. And that actually wasn't the problem. So the problem remained, and I did a little more poking around, and I found that there was a capacitor on the primary side of this switching transformer. This capacitor on the primary side was the culprit. I jumpered a used capacitor. I'll put in a brand new one. I just wanted to see if that was the problem, and it looks like it was, because if I just turn this on right now. Beep beep. We have a power good indicator, and I can now select my output, and there's no squealing, there's no system turning itself off. It appears everything's good. Now checking the output voltage. 24 volts as expected. Power supply is now being repaired. I'm going to reassemble everything, connect all the grounds, make sure everything's good. I'll put some fresh goop on some of these connectors just to prevent anything from loosening. And I'm going to order myself a brand new capacitor to replace here, because I took this out of like a stereo probably 7 years ago, if not longer. So I want brand new components that I'm swapping out, you know. There's the replaced culprit right there. And then all the swollen capacitors on the output are also brand new. And now we're just going to put it together.
So I don't really have any good footage to end this video on. I didn't record the reassembly, but thankfully this was a really straightforward fix, and the person who gave it to me to fix is really happy with it, so everything worked out in the end. And thank you so much for stopping by to watch, and hopefully pretty soon I'll have some more design videos where I make things versus fix things, but content is content, I guess. Anyways, thanks for watching, and take care. Have a good week or weekend.